AI might be getting bigger, but the real power struggle is over who controls it, and Mistral is betting that open, efficient models will beat bloated black boxes in the long run. Mistral, a French AI startup, has unveiled its new Mistral 3 lineup of open-weight models, signaling that it wants to stand shoulder to shoulder with the biggest names in AI while still doing things differently. The company's goal is ambitious: make advanced AI broadly usable by the public and more attractive to businesses than the offerings from tech giants that rely on closed systems. A two-part model strategy. The new release bundles together 10 models, a single large, frontier model with multimodal and multilingual abilities, and 9 smaller, offline-capable models that can be tailored heavily for specific needs. This combination lets Mistral compete at the cutting edge while also doubling down on compact, efficient systems. Mistral focuses on open-weight language models and runs a Europe-centric chatbot called Le Chat, but it has often been seen as chasing Silicon Valley's closed-source leaders. Open-weight models share their parameters so others can run and adapt them, whereas closed models like ChatGPT keep those details secret and only allow access via controlled interfaces. That difference sits at the heart of Mistral's pitch. Lean funding, big ambitions. Despite being only about 2 years old, Mistral has already raised roughly $2.7 billion and reached a valuation of around $13.7 billion. That might sound huge, but it is relatively modest next to OpenAI and Anthropic, which have each raised tens of billions and sit at valuations in the hundreds of billions. This funding gap is exactly why Mistral leans into the narrative that more money and bigger models are not automatically better, especially for companies with real-world constraints. The company wants to show that thoughtful design and customization can beat brute force scale. Why smaller can be smarter. Guillaume Lample, Mistral's co-founder and chief scientist, explains that many corporate customers begin with very large, closed models because they are easy to try and require no training or tweaking. Once those systems are rolled out, however, companies often realize the hidden costs. They can be expensive to run and sluggish in production. At that point, some customers turn to Mistral to fine-tune smaller models that can handle the same tasks more efficiently. In everyday enterprise scenarios, like support automation, internal tools, or document workflows, Mistral argues that well-tuned small models are enough, and sometimes even preferable. Benchmarks versus real-world use. Early benchmark charts may show Mistral's smaller models trailing the largest closed systems on raw scores, but Lample says that view is incomplete. Big models can shine straight out of the box, yet the real power emerges when a company customizes a model for its own data and use cases. Once models are adapted and fine-tuned, smaller systems can sometimes match or even surpass closed models on the tasks that actually matter to businesses. This raises a provocative question: should companies obsess over leaderboard scores, or over what works best in their real workflows? Mistral Large 3, a frontier model. At the top of the new family sits Mistral Large 3, a frontier model designed to rival leading closed-source AI systems such as GPT-4o and Gemini 2. It supports both multimodal input, like text plus images, and multiple languages, while also competing against other advanced open-weight models. Large 3 is one of the first open frontier models to combine strong multimodal and multilingual capabilities in a single system, putting it in the same conversation as Meta's Llama 3 and Alibaba's Qwen 3 Omni. Many companies still rely on separate models for language and vision, but Mistral aims to unify those abilities in one powerful engine. Under the hood, mixture of experts. Large 3 uses a granular mixture of experts, MO, design, with 41 billion active parameters out of a total 675 billion. This architecture allows the model to selectively activate experts for different inputs, providing strong reasoning performance while staying efficient. It supports a context window of up to 256,000 tokens, so it can process very long documents and act as a capable assistant for complex enterprise workflows. Mistral positions Large 3 for use cases such as document analysis, software development, content generation, AI-powered assistance, and automating end-to-end processes. Ministral 3, making the small models the stars. The more provocative part of Mistral's announcement is its Ministral 3 family of small models, where the company claims that small does not just mean good enough, it can actually be better. This is where the story gets controversial for anyone who believes only giant models matter. Ministral 3 consists of 9 dense models split across 3 parameter sizes, 14B, 8B, and 3B, and 3 usage flavors: base, instruct, and reasoning. Base models are the raw pre-trained foundations, instruct versions are tuned for conversational and assistant-style tasks, and reasoning variants target logical, analytical problems. Flexibility for real-world needs. Mistral says this range lets teams pick a model that fits their exact balance of performance, cost, and specialization. Instead of forcing everyone onto one giant system, developers can choose smaller models for lightweight tasks, or higher parameter versions when they need extra capability. According to the company, Ministral 3 performs at or above other leading open-weight models while being more efficient and generating fewer tokens to complete similar tasks. All variants can handle vision inputs, support context windows between 128K and 256K, and operate across multiple languages, making them broadly useful for global organizations. Designed for a single GPU. A core selling point is practicality. Ministral 3 models are engineered to run on a single GPU. That means organizations do not need huge clusters or expensive cloud infrastructure just to get started with advanced AI. This opens up deployment options ranging from on-premise servers and personal computers to robots and edge devices that might have unreliable or limited connectivity. It also serves use cases like students working offline, or robotics teams operating in remote areas where constant internet access is not guaranteed. Accessibility is part of the mission. Mistral links this hardware efficiency to a broader mission of accessibility. The company argues that powerful AI should not be restricted to organizations with massive budgets or perfect network connections. By keeping models open-weight and runnable on modest hardware, Mistral hopes more people, individual developers, small companies, and public institutions, can build and deploy AI solutions without depending entirely on a few dominant labs. Not just Mistral, others chasing efficiency. Mistral is not alone in prioritizing efficient models. For example, Cohere's Command A enterprise model is designed to run on only 2 GPUs, and its North platform for AI agents can function on a single GPU as well. These approaches reflect a broader trend. Businesses are increasingly interested in systems they can actually run and control, not just marvel at. This raises a bigger debate. Will the future of AI belong to a handful of ultra-large, centralized models, or to a wider ecosystem of smaller, specialized systems deployed everywhere from laptops to cars and drones? Pushing into physical AI. Mistral is actively pushing its small models into the realm of physical AI, embedding them into real-world machines. Earlier in the year, the company started collaborating on projects that put its models inside robots, drones, and vehicles. Partners include Singapore's Home Team Science and Technology Agency, HTX, for robotics, cybersecurity, and fire safety systems, German defense tech startup Helsing for vision language action models and drones, and automaker Stellantis for an in-car AI assistant. These collaborations show how compact, efficient models can power on-device intelligence without constant cloud calls. Reliability and independence over blind trust. Beyond performance, Mistral stresses reliability and independence as key concerns for enterprises. If a company relies entirely on another provider's API and that service goes down even briefly on a regular basis, the impact on operations can be severe. By offering open-weight models that customers can host and operate themselves, Mistral aims to reduce dependence on single external providers. This independence is a subtle but powerful argument against closed systems controlled by a few large players. The controversy beneath the hype. All of this leads to one of the boldest undercurrents in Mistral's strategy, the suggestion that the AI world might be too focused on size, hype, and flashy benchmarks. If most real business applications can be served by small, customizable models, then are we over-investing in giant systems that few can truly control or afford? And this is the part most people miss: technical performance is only one dimension of AI. Governance, accessibility, cost, and resilience may turn out to be just as important in determining which models actually win in the market. Your turn, what do you think? So here is the big question: should the future of AI be driven by a handful of massive closed models in the hands of a few companies, or by many open, efficient models that anyone can run and adapt? Do you believe Mistral's bet on smaller, open-weight systems is visionary, or unrealistic in a world where scale seems to dominate? Which side are you on? Bigger is better, or small and specialized wins in the long run? Share whether you agree or completely disagree, and why, in the comments.